First, there was Ada Spark.
Then, there was Rust. Then, there was Phil/C.
Coming soon, Zig CLR. Welcome to the new frontier in memory safety.
Hello to everyone who thinks that memory safety is important. My name is Isaac Yonemoto. Last December, I built out a proof of concept for some software called Zig CLR, which is a system that brings memory safety to the Zig programming language. Famously not a memory safe language. Let me show you how it works. So here I have a little toy program that I've written to demonstrate exactly how the analysis in CLR works. So what we're going to do is first we're going to kick off the CLR analysis, and then we're going to step through the program while that's running. So let me go ahead and kick that off. And here what's going to happen is we're going to enter the function main, then we're going to call alloc.create. This is roughly speaking the equivalent of malloc. We're going to create a pointer to a char, and then we're going to set the value of that pointer. Then we're going to call alloc.destroy, which is roughly equivalent to the C function free, and then we're going to dereference the pointer and return it. So if you look at this carefully, what's going on here is a use after free. So what that means is that we have freed the memory here by calling the alloc.destroy function, and then we are dereferencing the values pointed to by that pointer after we've already freed it. And indeed, what you can see is that CLR has correctly identified that it's a use after free. Here, the use after free occurs on line 13, column 5, which is this return statement here. So this return statement and the dereferencing that happens within it is responsible for the use after free, and it's also able to remind you that the pointer was freed in this function on line 12, column 18, that's right here, when we called it through alloc.destroy. Now, CLR is robust, and we can, for example, change up our code a little bit. So we can do this, and if I go ahead and run it again, this time the difference between this program and the previous program is that we've gone ahead and called a middleman instead of alloc.destroy. Now let's look at middleman. Middleman takes the pointer, a pointer to U8, in this case the pointer that we passed to it, and inside of here is where the free operation occurs via alloc.destroy. This is obviously still a use after free situation, and as you can see, again, CLR has identified that a use after free was detected in the function use after free on line 13, colon 5. That hasn't changed. But the pointer was freed in the function use after free dot middleman, so that's up here, on line 5, column 18, so that's over here again. So when it got called by alloc.destroyed. And then it also reminds you that the pointer was transferred from main to this middleman function, and that this middleman function was responsible for destroying it. A few notes on what's going on here. This is different from Rust because there will not be any implicit allocations or deallocations, and analysis is not going to be an integral part of the compiler. In other words, it's more of a checker than an enforcer. But in the end, it will still return a value that is catchable by, for example, CI pipelines, and it will prevent you from pushing these code that is unsafe to any sort of production environment. This is also different from Phil/C because all of the checking done is static. It's done, it doesn't require you to run the program in order to run. So to explain briefly how this will work in practice, you're going to compile your Zig program as you normally would, except you provide a slightly different command line. It certainly won't be this mixed CLR command line. The Zig compiler will then pass the intermediate representation that is generated by the compiler to a plugin that will then conduct analysis. The program will then never be run. And then Zig CLR will provide a comprehensive report of all of the faults that it has detected. So here's the exciting news. This December, I will be bringing Zig CLR out of the proof of concept phase and into a prototyping stage. My plan is to work on this part-time this month and have the prototype completed with the following features: undefined value checking, stack pointer escape checking, pointer allocation and provenance checking, structs checking, and full control flow support. So that means branches and loops. The last two of those features didn't exist in the previous version. I will be making weekly progress reports on CLR, and the project will, of course, be open source. If you care about memory safety with the good ergonomics of Zig, or about exploring alternative strategies to achieve memory safety, and you're interested in supporting this work, I've included a Buy Me a Coffee link, and you can make a one-time contribution to this adventure. Watch this space for updates.